We all wonder where we come from. We look at our parents, then our grandparents. We see hints of ourselves in them. It's a natural thing. We want to know our roots. And sometimes we get this big idea. Can we ever truly build our whole family tree? Every single person, all the way back. This isn't just about finding names in old books. This is about knowing our place in the long story of life. This is about evolution. It sounds simple. A family tree. You start with yourself. You add your parents. Then their parents. And it grows. For a few generations, it feels possible. You might have pictures. You might have stories. Maybe your grandma told you about her grandma. These are the easy parts. Relatively easy, anyway. You can find birth certificates. You can find marriage licenses. There are census records. These government papers are good. They list names and dates. They show where people live. They tell you who was related to whom. Yeah, church records also help. Baptisms, marriages, burials. These often go back hundreds of years in some places. They give you names. They give you places. They give you connections. And then there's DNA testing. The kind you can buy online, you spit in a tube, they send you back percentages. They tell you where your ancestors might have lived hundreds of years ago. They also find distant cousins. People you never knew existed. These tests are powerful tools for recent history. They confirm what you find in papers, they can break through adoption walls, they can fix mistakes in old records, they help fill in gaps. But even with all these tools, things get tricky fast. Their privacy rules stop you from seeing records for people still alive or recently passed. Not all records survive time. Fires happened, floods happened, wars destroyed towns and archives. People moved, they lost touch, they just didn't keep good records. Sometimes people didn't want to talk about the past. Secrets were kept. And that's okay, but it makes building a full tree harder. And then we think about numbers. This is where it gets really big. You have 2 parents. You have 4 grandparents. You have 8 great-grandparents. This doubles every generation. It feels manageable for a bit, but it explodes quickly. If you go back just 10 generations, that's about 300 years. You would have 2 to the power of 10 ancestors. That's 1,024 people. A lot of names to find. Go back 20 generations, about 600 years. That's over 1 million ancestors. 2 to the power of 20 is 1,048,576. That's a huge number, and we are still in what we call historical times. Records might exist for some of these people. For others, no chance. Now imagine 30 generations back. That's roughly 900 years. We're talking about the medieval period. The number of ancestors would be over 1 billion people. It was probably more like 300 to 400 million people. This mathematical problem tells us something important. It means you don't have 1 billion unique ancestors from 900 years ago. It means your family tree isn't just a simple branching structure. It has loops, it has overlaps. It means many of those ancestors are the same people. Your ancestors married their cousins. This is called pedigree collapse. It was very common. People lived in small communities. They didn't travel much. They married people they knew. These people were often related to them in different ways. So, the same great-grandparent might appear on different branches of your tree. This makes the idea of every single ancestor very complicated. Even if you found records for all of them, the tree would look more like a tangled bush than a neat diagram. It's a real part of our history. It shows how connected we all are, even within a few hundred years. Now let's go even further back, beyond paper records, beyond church books, beyond written history. This is where the evolution part truly comes in. What does a family tree even mean when we talk about thousands of years? Or tens of thousands, or millions? We are talking about common ancestors now. We are all related. Every human alive today shares common ancestors. If you go back far enough, you share common ancestors with every living thing on Earth. This is not a guess. This is what genetics tells us. This is evolution. For this deep history, we rely on different kinds of DNA. Not the spitting in a tube and getting percentages kind. We look at specific parts of our DNA. One part is mitochondrial DNA, or mtDNA. You get this only from your mother. She got it from her mother, and so on. It passes down a pure maternal line. It hardly changes. So scientists can look at your mtDNA and compare it to others. They can trace this specific female line back tens of thousands of years. They can group people into what are called haplogroups. These haplogroups tell you about ancient migrations of people. They show you the path your mother's line took out of Africa, or across continents. Then there is the Y chromosome DNA, or Y DNA. Only men have a Y chromosome. A father passes it to his son. It traces a pure paternal line. Like mtDNA, it changes very little. So scientists can trace your father's line back thousands of years. It also gives us haplogroups. It tells us about the ancient journeys of men. These are incredibly powerful tools. They show us deep connections. They show us how people moved across the globe. They show us when different groups diverged. They paint a picture of human history far older than any written word. But here's the catch, and it is a big one. Your mtDNA only traces one line in your entire family tree. It traces your mother's direct maternal line. It says nothing about your mother's father. It says nothing about your father's mother. It says nothing about your father's father. And definitely nothing about any of the hundreds, thousands, or millions of other ancestors you had in between. The same is true for Y-DNA. It traces one specific paternal line. It tells you nothing about the vast majority of your other ancestors. These are like two single threads pulled from a massive, complex tapestry. They are important threads. They are ancient threads. But they are just two threads. So when we ask if we can fully reconstruct our family tree, these tools only give us a very, very small part of the answer for deep time. They tell us about the long journey of some of our ancestors, not all of them. And what about other DNA? The autosomal DNA, the stuff that makes up most of our chromosomes. This is the DNA that mixes every generation. You get half from your mother, half from your father. And they got half from their parents, and so on. This mixing is why you look like a mix of your family. It's also why it's great for finding recent cousins. But the further back you go, the more diluted the signal becomes from any one distant ancestor. After just 8 to 10 generations, the amount of DNA you share with any single ancestor is so small it is almost impossible to detect reliably. It gets lost in the noise, it mixes away. So, for deep time, this DNA type doesn't help us find specific individual ancestors either. Then we have ancient DNA, or aDNA. Okay, this is a newer field. Scientists dig up old bones, old teeth. They extract tiny fragments of DNA. They can sequence this DNA. They can then compare it to modern populations. This tells us a lot about ancient people. It tells us about their genetic makeup. It shows us if they were related to people living today. It shows us how populations migrated and mixed. This is amazing work. It confirms theories from archaeology. It changes our understanding of history. It can show broad connections between ancient groups and us. For example, it might show that your ancestors were part of a specific migration wave from the Middle East into Europe thousands of years ago. But again, it's not giving you names, it's not giving you every single individual ancestor. It is telling you about the genetic makeup of a population that your ancestors were part of. It's like saying you are related to a whole forest, but not pointing out every single leaf on every single tree that contributed to your branch. The challenges with aDNA are huge. DNA breaks down over time and needs to be preserved well. Dry, cold places are best. A lot of ancient DNA is contaminated by bacteria or by people handling it. It is very expensive to extract and sequence, and there are ethical issues. We need to be careful about disturbing burial sites. We need to respect ancient remains. So let's circle back to the core question. Can we ever fully reconstruct our family tree? Every single name, every single person, from ourselves all the way back to the first life on Earth? The simple, honest answer is no. Not in the way most people imagine a family tree. Here's why. First, the numbers. We already talked about the exponential growth. The sheer number of individual ancestors you would have just 900 years ago is more than the entire world population at that time. This means pedigree collapse is not just a possibility, it's a certainty. Your family tree would be a complex, looping network, not a straight line of doubling. And this makes tracing every unique individual incredibly hard. Second, the records. Paper records simply do not exist for most people past a few hundred years. Most people in history were not kings or nobles. They did not have scribes documenting their lives. They were farmers, craftspeople, laborers. They lived and died without leaving a written trace. Their names are lost to time. And for the vast majority of human existence, there were no written records at all. We are talking about hundreds of thousands of years, millions of years. Third, genetics has limits. While mtDNA and Y-DNA show us deep ancient lines, they are only 2 lines. Your full family tree is made of millions of lines, crisscrossing and merging. Autosomal DNA gets too diluted too quickly to track individual ancestors in deep time. Ancient DNA gives us population-level data, not individual names for your specific lineage. Fourth, time and decay. Everything decays. Bones, teeth, paper, even stones wear away. The further back in time you go, the less evidence there is. It's like trying to find a specific grain of sand on a beach after 1,000 storms. Fifth, what does fully reconstruct even mean when we go back to the beginning of life? Are we talking about the first single-celled organism? Yes, we all trace back to that. But there's no tree in the human sense there. It's the tree of life. Your personal family tree merges with everyone else's. So, what can we do? We can reconstruct parts, we can build branches, we can find many names in recent centuries using records and consumer DNA tests. We can trace major migrations and broad genetic groups of our ancestors using mtDNA, yDNA, and ancient DNA analysis. We can connect ourselves to the great story of human migration out of Africa, or the spread of farming, or the pupling of the Americas. We can understand that all humans share a common ancestor relatively recently, perhaps just a few thousand years ago. If you go back far enough, everyone on Earth is related to everyone else. This is a scientific fact. It's a wonderful connecting truth. We are all branches of the same family tree. The idea of fully reconstructing our family tree, meaning my individual tree with every single person, all the way back, is a dream. It's a beautiful dream, but it's not possible. The scale of time, the numbers, the lack of records, and the nature of genetic inheritance just make it an impossible task. But this doesn't make the search pointless. Far from it. The journey of trying to trace our family tree is powerful. It connects us to history. It helps us understand where we fit in the world. It tells us stories of resilience, migration, love, and loss. It makes us realize that we are part of something much bigger than ourselves. We are part of this continuous chain of life. We carry the genes of all those who came before us. Their triumphs and struggles echo in our DNA. We are living history. And maybe that's the real reconstruction we should be after. Not an exhaustive list of names, not an impossible diagram, but a deeper understanding of our shared human story. A story of evolution, a story of connection, a story that reminds us we are all one family in the truest sense of the word. And that's a tree worth knowing, even if we can't label every leaf.